All I gotta do is take the fingers. Oh, that one's perfect.
All right. 5. What's that? All right, here you go. Here's 2 more. Number 5. Shh. I'm going to be writing here, but now what am I telling you to do with this? Don't write your answers, right? Now, what I suggest to write for answers, right on here. Pass that back, please. To the kids in the back. All right? 5. J. The mole ratio is a comparison of how many moles of one substance are required to participate in a reaction with another substance based on the balanced equation. True or false?
True.
Chantel, true or false? Yes, true. Good. Number 6. Use the balanced chemical equation to determine the mole ratio between this and this. Which one is a diatomic element?
The second one. The first one.
Diatomic means what, Brandon Porter? Two of the same thing. Very good. You knew that, right? What is this thing called? Is it an element or a compound? It's a compound, and it is polyatomic. It has more than one element. How many elements does it have?
2.
At least 3. You see how the white one, the dark one, and then there's a teeny one that's different. Okay? So that's at least 3 elements. Alrighty? Now, what is the mole ratio between this and this? Let's do a balanced equation. How many moles of this do you see? Or molecules, either one. 3. How many here do you have? 2. How many here do you have? So how many of these to these? Hey, we don't have a balanced chemical equation, do we? Or do we? Okay. Yes, we do. You're right. Jay, David, go stand outside the classroom, please. Come on. For 2 minutes. Go stand outside the classroom. Come on, Jay. Let's go. Because we're talking about this to this. 3 to 2. Okay? All right. Number 7. The table shows the mole ratios of potassium and bromine combined to form potassium bromide according to this balanced equation. This is hard, kids. Let's pay attention. Those of you who are aiming to make a 100 tomorrow, you need to focus on this, okay? In which trial is the amount of bromine the limiting reagent?
How do you read this?
How do we do this? How do we do this? All right. How about this? Shh. Now, we are using bromine to make potassium bromide. All right? If we have 3 moles of bromine, how many moles of potassium bromide can we make? 6. When we ran out of bromine, did we run out of bromine or not? If we used 3 of these to make 6 of these, how many potassiums were required to make? You know what this is? This is a 2:1:2 ratio. Okay? If we're making 6 moles of, there's different ways to look at this, so let's look at it this way. If we're making 6 moles of potassium bromide, all right, it would take half as many bromines to make that product. So this was the limiting reactant. How many potassium bromides could we have made with 10 moles of potassium? How many potassium bromides could we have made with that amount of potassium?
5.
10.
10.
Do you see that this is a 2 to 2 or a 1 to 1 ratio between potassium and the product? With 10 moles of potassium, we could have made 10 moles of the potassium bromide. Okay? So, did we make 10 moles or did we run out of bromine? We ran out of bromine, so that was our limiting reactant. This was our excess reactant. Let's look at this one now. Okay? If we've made 3 moles of potassium bromide, how many moles of bromine did we need? We needed 1.5. How many did we have? 2. Did we have more than we needed to make that amount? Yes. So this is not limiting in this case. What is it called here? Now it's excess. Is this the limiting reactant? It should be. Potassium, if we have 3, are we going to make 3 moles of product?
No.
Yes.
Yes, so 2 to 2 or a 1 to 1 ratio. This isn't easy, is it? Okay?
All you gotta do is remember the first and last numbers and if you're the same, then it's right.
Yes, you have to look at the ratio. All right, now, how many moles of potassium bromide did we make? 14. All right.
Ooh, that one's good.
If we have 8, all right, think of it like this. If I have 14 moles of potassium bromide, how many moles of bromine did I need? 7. I needed 7. How many did I have? I needed 7. I have 8. This must be excess. This better be the limiting reactant. If I have 14 potassiums, yes, I can make 14 bromine. So this was my limiting reactant. Yes, so the question is, in which trial is the amount of bromine the limiting reactant? It was only trial number 1D.
So since this is 2 to 1 ratio, then you could just divide it.
Yes. If you understand that, then you're doing great. Okay, and there are a lot of different ways that you can look at that. So you're looking at those ratios. Okay. Number 8. Gold is reacted with chlorine gas according to this equation. Use the data in the table to determine the percent yield of gold chloride. This is easy. We're just following our formula. Percent yield equals actual over theoretical times 100. Okay? What's my actual yield, kids? 35.2 grams. All I'm missing is theo. How do I find the theoretical? Stoichiometry. I said it was easy, but it's not, is it? Don't I have to do a stoichiometry problem here? All right, let's do it. Let's make this quick. All right. What do I want to find? This is the hard part. There's too many people sleeping, and I expect that you will be making zeros tomorrow. Or not passing. I'm writing down names. I'll keep it on hand and know that you are sleeping today, the day before the test. All right, what am I looking for? Grams of what, guys? Gold chloride. I want grams of gold chloride. How do I know I want grams of gold chloride? It tells us I want the percent yield of gold chloride. That's my product. Percent yield is all about the amount of product you're going to make. Right, Maggie? Okay. So I want to know grams. I forgot my G there. Did you add your G? All right. Good. Lamar, what's the given info that I start with? Which one of these numbers? The mass of gold or the actual yield? Mass of the gold. That's my mass of my starting reactant. Sammy, I always put it over 1 with no unit, right?
Yeah.
All right. All right, kids, this is a 3-step stoichiometry problem. Can y'all work it, or do you want me to do it?
What about we do it together as friends? I believe in us as a group.
Good. Austin B., what's this step right here called?
What it's called, I don't know, but you put AUCL3 in there.
How about I call it molar mass?
Let's do that.
All right, let's go. What does that conversion factor look like?
AUCL3, grams of AUCL3.
Where?
On the top, right?
No.
No?
No. I'm doing molar mass. Right now?
It's not, I'm trying to stay up. I need to move.
Is this where I'm trying to flip and do the reciprocal?
This is where you're finding molar mass. You're going from grams of gold to moles of gold.
Just redo the reciprocal back.
Reciprocal of what?
When you flip it, you do the reciprocal.
It's 197 grams
Do
of
that.
AU.
You have to tell me what the reciprocal of what, though. This is where I do my molar. Yesterday we flipped something that you did.
Yeah, remember how you were telling me to flip those 2 problems on that one we did?
Yes.
Try again.
All right. Hang on, Tyler. Kimberly, what unit do we just cancel out? Grams of gold. Sammy, what's my next conversion factor?
Wait, what'd you say?
What's the next conversion factor? Hmm?
Do another step?
Yeah, I'm using my mole map. What do I do?
Normal ratio. Alright. I didn't know what it was called, but that's what I was trying to get at.
You would
Now you
be.
get it from the,
Volumetric. Erlenmeyer.
okay.
I use my
Coefficient.
coefficients 2 to 2, right, Sammy? All right. Austin B.
Yes.
I canceled out moles of gold. I have moles of AuCl3. Now I can do what you were talking about and do molar mass where you can put your grams of gold chloride over 1 mole of gold chloride. Get David in, please.
David, come on.
All right, AuCl3, we're going to add together 197 for gold and 35.5 times 3 for chlorine. What happens when I do that math? Thank you. 302 G's per mole.
35.5.
35 is fine. All right, let's do a little bit of a calculation. What is 300 divided by, an estimation, excuse me, what's 300 divided by 200? What's 3 over 2? It's 1.5, isn't it?
1.5.
Yeah, very good. What is this number close to? 40. What's 1.5 times 40? Isn't it the same thing as 40 plus half of it? So 40 plus 20 is 60. Shouldn't we get a number close to 60?
It'd be like 57 something.
Yeah, let's do, all right, we've got our estimate. Let's do our, you know what? Let's do our calculation. I know I can count on Corbin. Brandon, what's happening? You're slipping. You're letting Corbin's practicing. I would be on his mole day team if I were you on Friday, by the way. Okay, what's the
We
answer?
are.
Just like for the whole thing.
Yeah,
I got 60.4.
60.
For the, I didn't do 35.5.
That's okay. That's okay. We're done. We're good. We're good. All right. Man, our estimate was pretty close, wasn't it? When it's time for mole day, you need to have a team that has 2 people who are willing to compete athletically and 2 people who are willing to compete academically. If you aren't hoping to be on a competitive team, I have jobs for you. We need people to help keep time, scorekeepers, All right, and then I also need somebody to be the head scorekeeper. That person needs to be highly responsible, and you have to apply for that job.
Should get to apply.
Is that project thing, is that optional? Or is that credit?
It's necessary. It is necessary. All right.
I haven't even looked at it.
All right. Now, 4. Now, shucks, we're not done with the problem, are we, kids? We're not done with the problem, are we? Wasn't it a question about percent yield?
Miss Milo, when is that holiday thing due?
I said tomorrow, but you can continue working on it tomorrow after the test, okay? All right. Now, we're going back. We'll talk about it tomorrow. Yeah, you don't have to have it completed tomorrow. I'd rather you study for your test. All right. Shh. 35.2 divided by theoretical. Now, guys, what's the theoretical yield? 60.4. All right. Guys, look at this. What's the answer going to be close to? You know what? Those numbers are actually fairly close, so we're going to have to do a calculation. No, it's too loud over here for some reason, that bottle. Yes.
It says that you were going to provide us with a mole graphic.
Yes, I've got some in the back, in one of those 2 drawers. Kat, if you wouldn't mind going and looking at that, that'd be great. All right. What is the correct answer? 58.1?
Yes.
All right. So the answer is C. Okay. Good. Number 9. What's the correct mole ratio of potassium phosphate to potassium nitrate? What do we have to do, kids? Balance, right? Josh, knock it off, please. All right. That's balanced. K3PO4 to KNO3. What's the ratio, kids? 2 to 6. I don't see it as a choice. Do you need to go tell the teacher that the choice isn't there?
You have to simplify it.
You have to simplify it. Right, Darius? Thank you. Correct answer is 1 to 3. That's the same thing as 2 to 6, so the answer choice is C. Number 10. How many grams of water are produced when 2.5 moles of oxygen react with hydrogen? Here's what you do. What's 5 times 18?
5 times 18 is...
C, 90 grams. All right, you see how to get that answer, right?
Yes.
Yep, write that down quick.
How many twice is the test tomorrow?
I don't know, it's usually very close to the practice test.